Hey Allie, what's up? It's Brennan, and I know you're going to have to teach quite a bit of this Unit 9 stuff yourself. So I figured if I made just a video going over the Unit 9 assessment, what that would do is that would be able to teach you all the different things that you'll have to teach Holden throughout the unit. So that way, as you're prepping what you're going to teach, you can have an idea of, what he'll eventually be assessed on. What I'll try to do too is after I do a question, I'll pull up the calendar and I'll look at it really quick and make sure I tell you which day the information would go with, and you can just reference back to this video as you do the unit and as you prepare the different kinds of problems you're going to be showing him. So let's get into it together. Here we go. Here's the assessment. For questions 1 and 2, we have this table. This unit is on statistics. It's quite different, of course, than geometry, but we're moving into it. This table shows 4 different students and what they wrote, and the assignment was for them to write a statistical question. And here's what they wrote. Erica, how many students are in the cafeteria today? Jamal, how many times do students get their hair cut each year? Robert, what is each student's favorite club at the school? And then Tiana asked, what is each student having for lunch today? And we have to select who did not write a statistical question, right? So this question right away, if we pull up the calendar, it is going to be September 5th and 6th is where he learns about statistical questions, and then he has an IXL on it. What you're going to tell him is statistical questions have 2 requirements. They have to ask a group of people, and they have to have they have to be open-ended. They have to have a large number of responses, right? So you can't just ask Jim or Eric or whatever. That's one thing. You have to ask a group, and then it can't be like a yes or no question, or it can't be like a forced choice. It has to be open. So let's look through under that premise, under those 2 requirements, and see which one works out. Erica, how many students are in the cafeteria today? Well, if she asked every student, are you in the cafeteria today or not, it would be a yes or no question, and it's just a fact. There are this many students in the cafeteria. It doesn't pose a question that's open-ended. Jamal, how many times do students... So reading the question, number 1, who did not write a statistical question? It seems like it's going to be Erica. Let's just read through to make sure there's no typos or anything. Jamal, how many times do students get their hair cut each year? So this is to a group because Jamal could go ask, a seemingly endless number of students this question. How many times do you get your hair cut? And there is an open number of responses. Students could say, I get it cut 1 time a year. I don't get it cut a year. I get it cut 12 times a year, whatever. This is addressed to a group of students, and there is a seemingly endless number of answers. Robert asks, what is each student's favorite club at the school? Well, again, he could ask as many students as he wants, and there's maybe not an endless number of responses, but there's a pretty good number of responses. There's a lot of clubs, and, students could answer that their favorite club is, art club or, music or video games or whatever. So Robert did do it correctly. Tiana, what is each student having for lunch today? Again, Tiana could go in that lunchroom, ask, a lot of students that question. And again, it's not a forced answer choice. The question is open-ended. Students could say a host of different things. So the only student who did not write a statistical question is Erica. So number 1 is going to be A. So again, when you teach statistical questions, just focus on those 2 things for him. It has to ask a group, and it has to have an open-ended number of responses, multiple responses, I tell students, right? So number 2, the question is not statistical that Erica wrote. Well, let's just see if we can address it, and then we'll look at the answer choices. How many students are in the cafeteria today? Well, there's not an open-ended number of responses to that, unless you said, how many students do you think are in the cafeteria? Then students could, estimate, but it's not that. It's just a fact, and people are going to say the number of students that are in the cafeteria. So looking A, B, and C for number 2, this question isn't statistical, this question of Erica's, because it's not numerical. Well, that's not why. There's going to be a number answer. Letter B, it's not categorical. Well, that's true, it's not categorical, but you could have statistical data where people are reporting answers that are categories and not numbers. So B is true, it's not categorical, but that's not why it's not statistical. It's just not a categorical thing. C, it does not have variability. This is what I'm looking for here. Variability is another way of saying, of course, it doesn't have multiple answers. There's just one answer. It's this many students in the cafeteria, so number 2 is going to be C. Okay, it's not a statistical question because it doesn't have variability. So I hope that helps you teach him statistical questions. That's a really good test item on those. For 3 through 6, Aurora plays the trombone in her high school band. The table below shows her practice times for 1 week. The first thing I have students do when they're going to get range, mode, mean, and median is I have them list the data from least to greatest, which I'll do in a second. Right away, I'll let you know this test item is going to correspond with what he's learning from you on the 9th through some practice together. And then IXL is on the 10th and the 11th, followed by a quiz, which will be on statistical questions as well as mean, median, mode, and range. Okay, so 9th, 10th, and 11th, this is what you'll be teaching them. Let's just go through quickly how to get these. I'm sure you have some sort of idea of what each of these are. Let's just make sure we're on the same page. Again, I'm just going to list in order. So we got 18 first, because that's the lowest number. So I list them least to greatest. 18, looks like 20 is going to be next. When students list these, I have them cross out as they go. Next is 22, and it's important to note, if there's 2 of something, just have them list it twice. So 22 happens more than once. You list it out as many times as it appears. Then 24, 48, and then we end with 56. Okay, so here's what we have, the range. The range is just the biggest number minus the smallest. So range is going to be 56, subtract 18. 56 minus 20 is 46. We have to add 2 back, so 48 is what it looks like. Or wait, hold on. Sorry, 56 minus 20 is 36. Add 2, so 38 is what it's going to be. So that's all range is. When you teach him these, you can kind of just give him definitions. I know he struggles to remember definitions, so you guys can, just practice them, drill them again and again. The IXL will have him do that, but that's what range is. The biggest number minus the smallest number. The spread, the range of the data. Mode. We say mode equals most common. Mode is the most common number. It's the one you see the most. It's the most popular. There can be more than one mode, or there might be no mode. In this situation, there's only one mode. It's going to be 22 because it's the most common number. The mean. The mean is the same thing as what you might know as the average. You just add all the numbers up, and then you divide by the number of numbers we have. Let's go ahead, let's get the mean. He might have done this already in 5th grade or in years past. Let's add them up there. 18 plus 20 plus 22 plus 22 plus 24 plus 48 plus 56. And there's 7 days in the week, so we'll divide that by 7. So the average, or the mean in this case, is going to be 30. It's easy to make mistakes as he's adding up a lot of numbers in a calculator, so he'll just have to take his time for this, but mean should be pretty easy. And the last one is a little bit tricky. It's called the median. Here's how we do this. We have all these numbers listed in order. We cross out from left to right, and I like to keep track counting left to right, so that way I cross out the same amount of numbers. So 1, 1, 2, 2, 3, 3, and then the number in the middle is 22, so that is the median. The median is just the middle. The median is the middle. Now, sometimes you might have a situation, like if I gave you, this is a random example, 4, 5, 6, and 8, and we crossed out, you'd have 2 in the middle. All you do is then take the average of those 2, right? So in this situation, 5 plus 6 is 11. 11 divided by 2 is 5 and 5/10. So in this situation, the median would be 5 and 5/10. So if you have 2, you just get the average of them or the mean of them. If you have one, it's just simple. Okay, I'm going to move on. For number 7 and 8, we have a box plot question. Okay, this is going to correspond with the 12th and the 13th, where you guys are hopefully going to use some data that maybe you make up or find somewhere to make a box plot with a number line. And then on the 13th, it has some answering questions about box plots in IXL practice. Let's get into it here. The U.S. Bureau of Labor Statistics tracks the price of a pound of chocolate chip cookies. Some of the prices are shown below. So we have $3.19, $3.50, $3.17, $3.50, so on and so forth. You can read. The box plot of the data is shown. Okay, so here's the box plot. Before we answer 7, let me just highlight some things about this really quickly. Hold on one second. On a box plot is splitting up the data into what is called quartiles. Okay? And here's how it works. You have the lowest point of data is called the minimum. The highest point of data is called the maximum. The line inside of the box is called, and he should already know how to get this at this point once you guys learn this, it's called the median. It's just the one where we list out the numbers from least to greatest and scratch them out from left to right. If there's 2 of them, you just take the average. Now, to get where H and N are, this first one is called Q1 or quartile right here. Quartile number 1. And where N is called quartile. Quartile number 3. How we get those is you split your data up and you find your median. Once you have all your numbers written out and you've found your median, you can take the lower half of data, find the median of that, and that is quartile 1. Then you go and you take the median of the upper half of your data, and that's Q3. And what this effectively does when you find Q1 and Q3, it's why box plots are useful in general, is each section of data, like from the minimum to Q1, that's 25% of the data. Then from Q1 to the median, that's another 25%. From the median to Q3, that's another 25%. And then from Q3 all the way to the max is another 25%. Now, it doesn't look like from Q3 to the max would be the same percentage of data as it is between Q3 and the median. However, it is because it's the same number of responses are in there. It's just the distance between the numbers might be huge because there might be an outlier, right? The maximum might be like way further from the other numbers, and all the other numbers might be close together. But what's important about box plots is that because you're getting the median, the middle number, and then the median or the middle number of the lower half, and then the median or middle number of the upper half, because you're doing this, you're splitting the data into 25 percentage chunks. Okay? So bearing all of this in mind, we can move forward. That's how you make a box plot. If you need more help thinking through that, let me know. I think you can, find random numbers and use resources to do that. But that's generally what a box plot does. It shows us the quartiles, our 25 percentage sections. Write the correct letter for each given term. Of course, the minimum is R. I kind of already did this. The lower quartile is the same as Q1, so that's H. The median is going to be right in the middle there. Doesn't always lie right in the middle of the box. Like this one's a little bit to the left. That's totally fine. The upper quartile is going to be Q3. That's N. And then you can't see max down there. I'll scroll down in a second. The max is B, of course. All right, I'm going to keep on moving. Now, select all the statements that are true. Remember, the key here for him to know is box plots split the data into 25% chunks. So right away, he can get rid of things like A. Well, A is the only one we can get rid of here because A is not like divisible by 25%. So it's good to know though, because sometimes they're going to ask them different percentage questions. If 25 can't fit inside of the number it's asking about, it just can't be. Like A is totally nonsense. Let's look at the other ones though. It gets a little bit trickier here. And let's see. B, 25% of the data, a quarter of the data are between T and N. That's only one section, that's a quarter, so that one's going to be true. C, 25% of the data are between R and H. R and H, that's only one section, so that is true as well. C, 25% of the data are between, we just did that one, sorry. D, 50% of the data, or half of it's between H and N. H is there, N is there. You can see there's two sections. H to T is one section, T to N is another. That's two sections. 50% is quite correct. So far we have B is right, C is right, D is right. E, half. 50% of the data are between R and N. R is there, N is there. One section, two sections, three sections. So between R and N, we actually have 75% of the data. So E is not going to be right. Let's check F. 75% of the data are between N and B. Definitely not. It looks like it could be because it's a huge section, but that's only 25% because that's one section. N to B is one section, 25%. So B, C, and D should be these answers. I hope that's clear. Let me know if it's not. Again, this is going to help you make a box plot with them and learn about these. And your big thing for box plots is there's 25% sections. We find the median, we find two medians again for lower and upper half, and we're working with 25% sections. Moving on. This next problem involves histograms. It also involves comparing data spreads. So you can see 12th and 13th are box plots and interpreting them on the IXL practice. The 16th is making histograms. The 17th, there's going to be two histogram questions. I will have a worksheet for you guys, and then he'll quiz on that. Now, this question also involves some distribution vocab, like all these words here: skewed, symmetric, gap, peak, cluster, outlier. We'll get to all those as we do this problem. Now, our histograms on the right, the study is that 6th graders were asked for the number of text messages they received on a particular day. A histogram representing the number of text messages a sample of 20 6th graders received in one day is shown. So this is our histogram. We got to repeat the following statement. We got to complete the following statements. A note about histograms when you teach them how to make them. The big key for understanding box plots, the one we just did, is quartiles, 25% sections. The big key for understanding histograms is intervals. That's one key. Intervals. And then the other key is knowing its measuring frequency. So in other words, I'll go back to that in just one second. Hold on. So we have intervals, and then we have frequency, which should be this axis. Sorry, it's kind of messy. So what's going on here, we don't have exact numbers. It looks like 0 is there, 50 is there, I don't know, maybe 25 is there. It looks like these are split up into about 5s if I'm estimating. This interval is between 0 and 5 text messages. Out of all the students that were asked about text messages sent, out of all 20 students, 4 of those students send between 0 and 5 text messages. The next interval is probably about 5 to 10. based on the survey results, there are 2 students who reported sending between 5 and 10 text messages. Now, so on and so forth. Of course, the thing you could find using histograms is to some degree mode, although you really can't even find mode because you don't know the exact data. Like, for instance, in this interval right here between 0 and 5, 4 students reported sending between 0 and 5 text messages, but we don't know how many exactly each student reported because we've categorized their data into an interval. Now, one more note on how these are made, and then I'm going to go into these questions. Here's one last thing. If some 6th grader answered this question and they claimed that they sent 5 text messages, if this interval is 0 to 5, that includes answers up through 5. So that would be like 1 text message, 2 text messages, 3 text messages, or 4. If somebody claims they send 5 text messages, they're going to be in the next interval. So intervals measure, like, if it's, again, 0 through 5, would be 0, 1, 2, 3, 4, but then 5 would be inside of 5 to 10. 5 to 10 would measure 5, 6, 7, 8, 9, but if you're in 10, you're then in 10 to 20. Once you're the upper limit of what the interval says, you're actually into the next one, which I get is very confusing. That's just the way it is, and it's a nuance I wanted to share. Okay, moving on to the questions now. We have this good histogram, okay? And what we can really do from histograms more than any other thing, because we can't really get range, mean, median, or mode, because we don't have exact data points, but what we can do is we can really make some good conclusions about the data. We can do data comparison. So first off, number 9 asks the shape of our distribution. The shape. Now we have skewed, uniform, and symmetric. If you have what's called an outlier, that means data that's way removed from the rest, you know your data is skewed. So 9 is going to be letter A, and you could actually say skewed right. We skew in the direction of outliers, so this data is skewing right. Uniform would be, okay, look at this interval here between 1 and 5 is at 4. If every single interval was at 4, pretty much, we could say it's uniform. That's not true. It almost never will be, unless you asked, I don't know, just a question that would have the same answer for everybody or something, but it's not uniform. And then symmetric would look like what people know as the bell curve. So if the data follows something like this, right, or you could say if the data follows, maybe there's an inverse something going on. If the data followed something like that, then you could say symmetric, but it clearly doesn't. The only right answer here is skewed. So that's what those vocab words all mean. The distribution has a blank between 40 and 55 text messages. 40 and 55 text messages. Well, let's see. We have to use our imagination here a bit. We know 0's there, 50's there, the halfway point's 25. So 40 and 55, I take it they're probably referring to that space right there. And that's what's called a gap. A gap is an interval that's not populated. There's no data for it between 40 and 55, right? So that's a gap. The peak just means the highest interval, the interval with the most frequency. For us, that would be between 0 and 5. And then let's see what else is going on. Ooh, actually, I might have misread this question. 40 to 55 wouldn't just be this skinny little one. That would be 40 to 45. 40 to 55, 40, 45, 50. That's actually talking about, I'm sorry. Let's look at this again. That's actually talking about this right there. So it's actually not talking about the gap. I'm sorry, that's my bad. It's talking about what is known as the cluster. And I'm sure you can guess what cluster means. It just means data that's really close together. A lot of this stuff is kind of self-evident, but I want to teach it to you to make sure you know how to explain it to him. A cluster, again, it's just data that's really close together with no gaps. There's a cluster there. You could also make an argument that there's another cluster right here. Of course, this one's an outlier. You get the picture. That's what's going on. That's what those vocab words mean. The distribution has a blank between 20 and 30. We know what all these vocab words mean now. Let's see, between 20 and 30, I take it that would be this. Yeah, 20 to 30 is that. That one's definitely looking for gap. That's what's going on there. And then the distribution has an outlier between, and then we just have to say which one this is. It's going to be from 100 to something, so can we get rid of any of these? Yeah, definitely not 55 to 100. Definitely not 30 to 35. It's going to be 100 to 105. That's where that outlier is here. All right, our last question is a multiple choice question. It's on dot plots, okay? And this is going to be, it's going to match up with the last thing he is learning in the unit. A dot plot is also called a line plot. He's going to learn it with you on the 20th. You guys are going to make a line plot together. And then he's going to do some IXL practice the 23rd. Comparing distributions is the stuff we just talked about. So we've already talked about those words: skewed, symmetric, gap, peak, all that. He can use line plots for that. He can also use line plots, and histograms are going to be the most useful, although you can use box plots. I'll have some worksheet practice for him the 25th. And then he'll be into study guide and test review. Let's get into line plots on this last question. The way that you make a line plot, let's get into this. The way you make a line plot is you'll have a bunch of data. You figure out the right scale to use. So sometimes it'll be decimals like this, but you could easily make one without decimals. And then all of the dots are showing, or you can imagine the dots are like individual responses to a survey. So this one, for instance, the cost in dollars of a healthy meal in 20 countries is shown on this line plot. So $2.75 for a meal. There are 1, 2, 3, 4, 5 countries where that's the cost of a healthy meal. For $3, 1, 2, 3, 4, 5, 6, 7 countries where $3 is the cost of a healthy meal, right? So line plots are really easy. They're the last thing you guys are going to make in the unit, but they're refreshingly easy, and we can tell a lot of really good information from them. Letter A says the data is skewed. We know the data is skewed if there's an outlier. There is an outlier out here. It's actually going to be skewed right, so letter A is certainly correct. Letter B, the data set is normal. Again, normal would mean it fits a sort of bell curve. Or another word for normal is symmetric. It looks the same on each side. Definitely doesn't. You can tell it's skewed here. So A is right, B is incorrect. Let's see, there's a gap between 4 and 5 and 2500ths. There is a gap there. That is true. Right on 4 it's populated, and right on 5 and 2500ths it's populated. But between the two, there's a massive gap. So I like A, I like C. D, 5 and 2500ths is an outlier? Yep, definitely. It's fine. It's separated by a huge gap, so I agree with that. And then 3 is an outlier. 3 is not an outlier. 3 is actually the mode, right? Because 3 has the highest frequency, and it's not like a histogram where there's an interval with frequency in it. The frequency is actually 3. It's like a bunch of countries answered that exactly $3 was the cost. It's the most popular answer. So 3 is the mode. It's not an outlier. An outlier is this one, because there's only one country with it, and it's way more expensive than the others. All right, Allie, I hope that helps you as you teach this unit. Like I said, where it says, worksheet practice worksheet, all that stuff, I'll get you all that stuff. I just wanted you, again, to have a video to reference as you prepare to give him some notes on stuff. And, really you could think of it this way. You're giving him notes on statistical questions. You're giving him some practice for mean, median, range, and mode where you do it together. But everything else in the unit, you're making a graph together. So you're making box plots together. You're making histograms together, okay? And then you're going to make line plots together. And I would make them together, and then I'd give him some crucial info. And then that IXL practice will be really good too. All right, Allie. Thanks.